we find difficult when is to be filed the patent. What is the basically idea behind the patent? So that part we are going to discuss it. And I am having some outline I put it for my presentation. So outline is like this. So we are going to discuss first of all, not about the patent, but we are discussing about the few case studies for it. So reason for discussing the case studies is that we should know at what stage or what kind of an ideas are to be patented and what kind of problems we people have to address during the patent. So that few case studies, maybe three to four, five case studies I'm going to discuss. And then we are going to discuss what does that patent means and what is the way we can go for a patenting, what its requirement, and then what are different types of patents, so many things we are going to discuss into this. So basically, I will start with case studies, and these are whatever the red color indicate those case studies I'm going to discuss. We have so many bunch of the case studies, but out of that, only these 5 to 6 case studies we are going to discuss. So one is stereolithography system, then scanner, then smart helmet, blood warmer, manual scanner, oxygenation device. There is one more patent is a multi-purpose container, footrest for the two-wheelers, and linear compressors. So many things we can go on discussing about this. So when we are going to have a patent, we patent or I will just keep this patent word itself as somewhere away, and then we'll now discuss about how to solve the typical engineering problem. So I will give you one simple example, that is a helmet. So even we are having a compulsion in the government to wear a helmet. People are very reluctant to wear the helmet, and obviously that is people are again drinking, driving the vehicle. Obviously there will be accidents caused due to this. So many things are going to happen, but nobody has started what should we control it. We can apply the rules, and we can ask the driver, show us your license, and so many things we can ask. But the thing is happen most of the time, whenever the vehicle that person is going to drive the vehicle, that particular person is not available, means that is a policeman or our cop is not available to ask him all the time. So why should we keep such things? Why cannot we have something automated system? So that's what the reason is, that then we decided to go for such patent. So basically, when we are addressing any kind of a problem, first of all, identify the basic fundamental of the problem. What is the problem in that? So basically, fundamental problem is lethargy of the drivers of two-wheelers to wear the helmet. That is, they are more, they feel more uncomfort, and whenever they are putting helmet onto their head and driving the vehicle, and they can't feel free or something. So that is one reason. Another one reason is that, so most of the people drink and drive, and that is nothing but a cause of accidents and comes to some safety issues. And per year, maybe 5 to 6 thousand people die due to the accidents on the roads. And why? How can we address this issue? So what is the basically? So this is what a problem, and to save the life of the human being. So what is the existing problem? Existing solution is helmet is there, but it's not optional for the driver. Means it is not a compulsion for the driver. Then we can't identify whether he has drunk it or something. So that is also another problem, and we can't go for it. There are separate systems available for this. Then the helmet, whenever you are going to drive something, the helmet doesn't need any power source actually currently. So that is what on a existing problems. Then we why cannot we have something new into this helmet? We cannot be given a new features for this. Helmet is there. We are not going to file the patent for the helmet. But what is there are new features we are going to include. We will discuss this. Helmet is initially as an optional part for the driver. Why cannot we make it compulsion? We can make the compulsion by providing rules and regulation on the road safety or something. But that is also not all the times possible. So then there will be some safety system in the helmet itself. If you are going to drive, then vehicle will start. So that way we can plan it. That was the thing one way we can plan. Another one, whether we able to identify the drunken driver. If you could identify, do avoid him for driving the vehicle. So that also we can do it. But when we are going to operate that electronic part, we don't have any power supply. So we can put up a power source onto this, and then that is solar powered operation, we can do it. Now look at the system which we propose. One of my student, Amit Dusani, just now I had a call with him because we are having in a final stage of this patent, means we are reaching to the grant of it. So basically, whenever we are going to have a pet wearing the helmet, the problem is that whenever wear this helmet, my vehicle doesn't know whether I weared this helmet or not. So why cannot we connect this helmet and vehicle by either wirelessly or maybe Bluetooth or any kind of connection? So when I wear the helmet, automatically that vehicle is going to identify. That is what in a smartness we put it. And that Bluetooth will now generate on a signal. It goes to the microcontroller, then operate the relay. This is one condition. Another one, the vehicle, that driver will have a key, and both the conditions should satisfy. The person is having a key as well as a helmet. Both the things, you can take it together, and then ignition switch will start, and then vehicle will start. That is what basically sequence of operation we can do it. One more thing we included, that one more condition we need to include, because most of the driver is drinking, and you are not, you don't want to allow him to drive it. So in that case, we can have one more condition, that sensor we can put it, which will detect the alcohol continuously, and that if person is going to use that helmet and vehicle, it will avoid to use if the driver is drunken. So that kind of conditions we can put, and we can have a patent onto this. To operate this, we need a power source. So for that purpose, we can mount a power solar panels on the helmet itself. It will, that is not huge power it needs to operate this microcontrollers, maybe 50 to 100 milliwatt power, and that can be generated from a very small solar power devices. Along with this, also we provided in a few features on it. What are those features? If vehicle is going to move it to the right side or left side, you want to have an indication, we can have an LED array onto it. So it will indicate left, right indication, left indication, and also we can have a stop indication. So many things we can include it into, and we can provide more features onto that. This is what the one example as in a patent. Another one, so most of the, when you go to the doctor, and if a person is in having some critical condition, most of the time we need to provide enough blood for him. So whenever we are going to provide enough blood, so doctor takes in a blood bag from the refrigerator directly, and that temperature of the blood is approximately around about 8 degree or less than that, 8 degree. So that small lower temperature blood, if you're going to give it to the patient directly, so there is a problem with a patient, that he may suffer from hypothermia and may have issues with some reactions he will get. So that is what a problem. So normally what they do as a doctor, they take this blood bag, they put into the hot water. That hot water is mostly more than 50 degree or 60 degree temperature. Then let that will be there for 5 to 10 minutes, and then they take this bag, and then they will start injecting the blood into the patient. So in that case, what it happens, basically when you increase the temperature of the blood, so there is a limitation of the blood stability, or whatever the component of the blood, maybe an AHB, your white blood cells are there, red blood cells are there. As we increase the temperature, they will get damaged, and they will not be much more useful when it is going into the patient's body. So to avoid this, so when obviously you need in a lower temperature, and this is very easy solution we got it, but there will be one system we can propose it. So key that, why cannot we control and temperature perfectly onto this? That is what a blood warmer. We are going to warm the blood. which is cold and can kept into the refrigerator. So what is this? Basically, we done it is a blood bag is there. So having in a low temperature, then we can inject into the heat exchanger. This is what on a very crude level heat exchanger we designed in initial phase. Later we designed in a very smart and a simple, easy device. So here there will be a heater, there will be a power supply for this, then thermostat is there. It is going to monitor the temperature of coming outlet of the blood, and there will pay, it will inject into the patient. We can have a separate power supply for all control and operations. So this is kind of a system which doesn't exist currently. Why cannot we go for a new idea? This is what in a new idea where we can rely and you can go for filing the patent. Then we decided to file a patent. Later we decided this is entirely kept into the liquid. Liquid is going to heat it. So then we decided this liquid may get leaked and may disturb everything. To avoid that, we provided a dry kind of a heater, and that also will be much more helpful for this case. So this is what a typical patent, and whenever you are filing the patent, you need to provide all the component details, not in the names as we write into your journal publications, but we need to represent in terms of a number, and that numbering we need to provide into appropriate sequence. That is what these numbers. Here you can see in a heater part, then there will be a power supply, then this is a coil, and then blood inlet, blood outlet, all these details we need to provide. So this is what done within a three to four of my students. One is Advait, another is a Kiran, and Shubham. All these three people are now currently working in different companies. Advait is having his own startup, and Shubham is also now currently in Germany for an MS. So so then we'll now discuss about another problem. So we have discussed two problems. One is about smart helmet. Another is about blood warmer. Third one, we'll now look into the oxygenation device. So there will be no conditions in the patient, condition of the patient. That is what a CICV condition they normally call. So CICV condition means can't incubate, can't ventilate condition. Patient may be in critical situation. In that case, what will happen that we need to pump the oxygen directly into his heart, or into the heart, and we need to continuously maintain that oxygen level into the body. So in that case, the currently the problem is solved in this fashion. This is what a representation of the heart. So what are the bag you can see, that is nothing but a representation of heart, and this representation of the heart. This is a representation of heart. This is what an oxygen pipe, and this is what the valve through which we can pump the oxygen into this blood. You can just look at how this works. So when you close this, oxygen is going to fill into the nest bag. So that is what the manual way the people will operate this entire system. This is what another oxygen pipe and this all. So when you are going to pump the gas into this, so manually all the time we need to operate it, because this medical, most of the medical instruments are not still under development stage. And why cannot we have a kind of an automated system for this? And for this automation, we should know what is the level of oxygen available into the that particular patient, and based on that it will now decide the switching and amount of flow rate, and so many things we can decide it. So then we decided to develop a one patent for this. So this is what on a patient, and this patient will be monitored with his pulses, how many pulses currently he is having it, and also monitored with an SpO2 normally we call, that is what an oxygen monitoring system. And these two parameters will be taken as an sensed into the patient, and based on that it will give it to the signal to the microcontroller, and there will be a decision maker, that is a touchpad is kept onto this. And this decision maker is now connected with this is a solenoid type of actuator device. So which will on and off the section. And this is a T section normally used for switching the on and off of the oxygen content into the human body. So this is what an oxygen cylinder. And so normally you can't provide 100% oxygen to the patient. Obviously, we need to mix it something. And that too also we need to maintain the pressure. If you provide in a high pressure also, it will create a problem. If you provide low pressure, oxygen will not go into the patient's heart, and that may create a problem. So in that case, we need to now also have a control on pressure of the gas going, or oxygen gas going into the patient's body. So this is what an entire idea is, new one. That's what is filed in a patent. So then another one is a manual scanner. Most of the time, whenever we want to have an accurate motion, so you may be knowing that lathe machine is having hardly 50 micron accuracy, manual accuracy is in 50 micron. And then if you are going for a vernier caliper, you will get an 100 micron accuracy. And if you're going for micro stages, that is a micro stages are screw gauge having a 10 micron accuracy, and you can't go beyond this time 10 micron. That is what the limitation. The reason for this limitation is there is a backlash into the system. There will be a friction into the system. We can't come out of this. That is what basically a problem. That's what we can't go for a very precise motion into this. And also there is a possibility key. I want to have a screw gauge, and I want to rotate it. So 0.5 pitch means when I'm going to rotate it completely, that 360-degree rotation. So my stage or nut will traverse within a 0.5 distance, and I can now given a marking on it. So that marking can be in a 10 micron, maybe something. And based on that, I can now go on providing in a precise motion for this. So whenever we are using such stages for micro application, where I need an accuracy of a 1 micron or maybe a sub-micron level, so we find a difficulty into this. So to avoid this kind of a difficulty, there will be there should be a certain system which will really takes care of this, and it can have a lower accuracy. That is what I can get an accuracy around about 1 micron or less than that. So for that purpose, there are certain existing solutions. So people have the automated scanners available into the market, but they are too much costly, and that is what it is not affordable for maximum people to use for this. Then we decided to go for some new innovative idea for this. What is this idea? Is that basically it is on the same idea we pick up from the screw and nut type of arrangement. When we rotate this nut, there will be two screws are there. One is a right-handed screw, and then another is a left-handed screw. So this right-handed screw and left-handed screw, both are manufactured, both are under one single rod, and there will be a conical shape. You can just look at this picture. There is a conical nut is provided and having a certain angle for it. And this angle is typically decided to get the motion to be amplified or de-amplified or kind of things. And then whenever you are going to rotate this right side or left side, so these cone, either it will come towards each other or they will go away from each other. And due to that, what will happen if I rest in a certain stage? This is what the stage. It will generate a perpendicular motion onto this. And that motion is decided by how much amount of these nuts are going to traverse towards each other, maybe away from it or towards each other. And now I can put this on spring-loaded kind of a system. I can put so that this what are the rollers mounted for the stage is completely attached continuously onto this. And later I can provide an appropriate friction-free surface like a roll-on coating or kind of things onto this, and I can get in a lesser and lesser zero kind of friction also. Whenever you are going to rotate this, and what is going to happen, what are the motion, output motion, depends on angle of this theta. If I provide this angle 45 degree exactly, so what will happen if I'm going to give an a 1 mm distance here as an input, output also provide me 1 mm. If I provide an angle theta more than 45 degree, so if I'm going for an 1 mm, output may be 0.5 or less than 1 mm all the time. That is what it is called as a de-amplification. And if I provide a larger angle or lesser angle, then I will get an amplification kind of things. That may depends on what amount of angle you're going to provide it. So now I can now have in a system where I can design this conical angle will now decide what will be the accuracy or what will be the motion, what will be the amplification of the motion for this. So that is what the basically idea, and based on that, we decided to use this as in a one simple device in all stages, micro stages or precision stages. So in this case, we decided to have only one single stage, which is spring loaded, and this motion is generated in vertical up and down direction. So whenever you are going to have a rotation of this, it will create a one motion. And the amount, if I provide a angle for this is less than that, de-amplification, and if it is a more than that, amplification will happen, kind of things will be done. Though based on this, we decided to have an XYZ stage. And that is what it is patented. This is one stage, this is another stage, and then there will be a Z stage also. Like this, we can provide XYZ manual stages for this. So then another one, the similar, this is what on a stage, and when you want to have a control of it. So it becomes difficult. We need to mount on some sensors on it, and we need to control it. So that is what on the next part of it, we next patent we filed onto this. But this, what are the mechanism we use in a flexural mechanism? Flexural means what it happens when you apply any force onto component, there will be a kind of a flexibility, means it will deform it. And why cannot we take an advantage of this deformation? And for that purpose, we decided to use beams or hinges to create a predetermined motion. We can design this mechanism so that there will be an XY motion or kind of things we can do it. But to get in a more precise application or more accurate scanning, so actually we are using a position sensor. If you are going to use a sensor around about 50 nanometer or something, that sensor costs approximately more than 1 lakh or approximately up to 1 lakh rupees. And for one single sensor. And along with that, we are using a data acquisition system, then control system, so many things. And obviously that entire precision scanner mechanism itself will have a more cost it is involved. So why cannot we have a lower cost sensor? That is one thing. Another, why cannot we remove the sensor from my feedback itself? That also we can do it. So that is what basically idea. And feedback control with highly precise sensors is a current solution for this. So this is what a typical mechanism is used. Here it is optical encoder is used, which is having a Renisha optical encoder with a 50 nanometer accuracy. This 50 nanometer accuracy sensor approximately cost about 75 to 80,000 rupees, and this manufacturing of these beams, you can say it, which will give me a precise motion. So for actuation purpose, we use an actuator. That is what on a Y-square actuator it is called. Y-square actuators are simple. This is what in a coil, and there will be a magnet. So whenever you are going to assemble this and provide a current into the coil, what it happens, it will generate an opposing magnetic field. And due to that, it will generate a force. And one part of this coil is mounted on stage, and another part, that is magnet, mostly it is kept onto the fixed stage, and we can get in a traverse in one direction. So for this purpose, if you look into this wise coil, so this whatever the motion happens is due to the bending of the beams. And in previous lecture we saw there is an analytical model. We can model quite easily using this. We need not to worry. There will be no friction. There will not be backlash into this type of mechanism. So there is no problem in predicting the motion of this. That is what basically idea. And for that purpose, we can now have a model for it. So whenever you are going to control the entire this XY planar mechanism, what we have on a XY planar mechanism here, then we can have a one position sensor here, another position sensor here. And so these are the two optical encoders used and given into the feedback. This is my reference signal and control system will be actuated. So this is basically this cost you can't avoid it. This cost we can't avoid it. If you could able to remove this and we go for a lower cost sensors, we can easily reduce the cost of this entire scanning mechanisms. For that purpose, what we decided to go into the depth of how this actuator works. This actuator itself is working in both the dual. It is working as an actuator as well as a sensor. How it is going to happen when you look into this actuator, and if you look into the components of actuator, there may be a property like a resistance of the coil, maybe a inductance, and these properties. And what are the voltage you're going to apply across this coil will be divided into three component voltage across the voice coil actuator. One component is in voltage drop across inductance, drop across resistance, and drop due to the velocity, relative velocity of your magnet and coil part. And that alpha is nothing but a motor constant. That motor constant is nothing but a connection between your electrical system and mechanical system. In electrical system, we provide a current, and mechanical system we convert into the force. So, what is the relation between this? That is what it is. Alpha decides, and that is what connected with your what are the magnet flux and what are the length of the entire coil. These two parameters plays an important role. So here it is only one single parameter you can observe. That is what in a dx by dt. That is the velocity of it. And if you separate this and we keep all the components and all the terms on the right side of this, and if you integrate it, you will get an equation, and that equation is nothing but going to tell us an uh, position of my coil relative to the magnet. So that is what you want to do. Actually, when you look into this equation, you can just observe there is a voltage is there is a current is there is a resistance is there, inductance. In resistance and inductance are constant property, that doesn't change. But only change is going to happen, that is how much amount of voltage drop is there, how much amount of current drop is there. If you could able to monitor this voltage and current precisely, maybe in micro amperes and micro volts or somewhere, so in that case we can quite easily determine position continuously. That is what an online position you can do it. So then we decided to now remove this optical encoder by position estimator. And this position estimator needs a voltage measuring device and current measuring device. These Ra and L is the constant. We need not to measure continuously. Only the changing is nothing but a current and voltage. And if you provide these two parameters into this equation, you will get in a position for maybe relative position between magnet and coil. And what are the rest is the position is due to the flexibility of your entire mechanism. And then we can provide into the loop, and you can develop your entire mechatronic system or control system based on this. So for that purpose, what we decided to go for XY mechanism. This is what on a double flexural parallelogram mechanism. So this middle stage is moving in this horizontal motion as well as vertical motion. This is XY stage, you can call it. And these two optical encoders are mounted on this particular mechanism. And this optical encoder is continuously giving to the microcontroller. And there will be a PC which is used to either control or monitor this entire stuff. And there are voice coil actuator which will generate the motion for this mechanism. So what are the current and voltage going into the coil? This is what white current and voltage measuring devices. So this current voltage measuring devices again generate voltage in terms of an analog signal, and then that can be given to the analog to digital converter into the D space. And this is what a linear current amplifier which will amplify the signal coming from the microcontroller. Maybe typically gain is 10:1 as well as 2:2, 2 as in a linear current amplifier gain, and then we need a power supply. So when we connect this, so actually what it happens, we can later, for initial purpose only, this optical encoder can be used. And later we can remove this optical encoder, and the entire stuff will work through this current and voltage monitoring system. And this will work like in a position estimator for this. And this is what in a new way of thought process, which it will avoid the entire use of optical encoder from the low, and later it is used only for validation purpose, because we don't know how much current what will be in a position. So for initial purpose only, for test purpose only, we can use an optical encoder. So this is what in a typical circuit in initial stage we designed it. And this circuit itself is our entire system circuit, and this entire system is nothing but a new idea, and that is what we filed in a patent for it. So this is what in a practical system. This is what in a we later we tested experimentally what will be the output and kind of things. And we observed that for a 500 micron position, we get in a somewhere 5 micron accuracy or something. So that is the way you can get in this sensorless operation, because we are not directly using in a position sensor for this. So that is what it is called as a sensorless operation. And then we can have an XY position and circular motion. Also, you can have any kind of an motion for this, and so many things we can do it. So मी परत बोलतो खाली तिचं अडकवलेस. Then this is what the way you can have an XY positioning and all these things. This is what on a one position and accuracies we are getting 5 micron. If you tune up more in more detail, we can get in a more and more accurate kind of positioning. That is what on a 2D XY scanner. So for this purpose, we filed an Indian patent also and US patent also. And one of our students, Zambre, was working in Purdue University, Indianapolis, and then we filed in collaboration with Purdue University at this quarter. So these are the people working that Dr. Sharad Muik was a major contributor into this. Then Rishikesh was there. Then Mahesh Shawade was there. And this Ali Razvan is from US, Purdue University, was supported this to work in both the places, like in India as well as in US. So then last case study I will discuss, and then we'll move towards what the way we can file the patent. So last case study is nothing but my PhD problem. I put it into hardly 2-3 slides for this. So idea behind this problem was that there is a stereolithography system currently exists. And that stereolithography system is scanning the laser in X and Y direction and curing the part that liquid is converted into solidification. So whenever we are going to convert liquid to solid using a laser beam, so what are the size of the spot on which it is used? Or I can say if I am having a very small interaction between liquid polymer and laser spot, I'll get in a very small features into the stereolithography or any 3D microfabrications kind of things. So if you keep this interaction very small and scan it with more accuracy, you will get in a more and more accurate kind of a component. So that's what currently limited accuracies maybe in a 50 to 60 micron or 100 microns. Then it has an also limited speed because we want a more accuracy. That's what we go for in a very small speed, that is a 2 mm per second. And also sometimes it is in a size of micro fabrication is a 5 mm, or that is what another limitation. And to break up this limitation, we decided to go for a system. So this is what a galvanomirror system is, an optical system, optical beam delivery system, that which will take on a laser beam, tune this laser beam, make it focus it, and hit to the resin mat. Another one is a mechanism which will create an XY motion for this. In this XY motion, what it happens, this galvanomirrors are typically used, but whenever you put up a lens onto this, that spot characteristics, it changes. We'll just revise this different scanning mechanisms for this. So basically, accuracy is nothing but due to two parts of it. One is an optical system, it is used for it. Another one is a scanning mechanism. What is the accuracy of the scanning mechanism? Both will go hand in hand, and they will decide what will be the accuracy of my fabricated micro component. So for that purpose, we first of all decided to identify what are the currently people use this scanning mechanisms. So first is scanning mechanism they mostly use as a post-objective scanning mechanism. In this post-objective or galvanomirror scanning, so lens is kept here. That is what it is typically called as an objective, and there is a mirror. This is another mirror. So when you look into this mirror, when there is a rotational symbol is given, when you rotate this mirror, my scanning on the resin surface will be y direction something. And if I rotate this M2 mirror, it will have an X position scanning. So whenever you are going to use this system, there is a lens and then it will start focusing and it will exactly focus at this point. But as it is going to scan, it will create a spherical focal surface. It is not creating a horizontal focal surface. If my resin is spherical, I can't keep this my resin continuously spherical. So for that purpose, what is to be done? So my scanning means my spot has to move from focus to then a certain more distance, and then that is nothing but a defocusing, and that is going to increase the spot size, and also it is going to distort the spot also. So that is what a limitation for this galvanometer scanner. And then people have decided why cannot we go for another one which will avoid this problem. And then this is they move this lens from this position to mm, after the scanner. That is what in a pre-objective scanning. This is a post-objective, this is objective, and then post of this objective, the scanning is there. Here it is a pre-objective, this is the objective, and before that, scanning is done. So that's what it is called as a pre-objective. But in this case, you can observe there is a one axis that is a lens axis. Another one is a beam axis. It is continuously changing. It is not maintaining that axial alignment between optical axis of the lens and the laser beam axis. Due to that, what it happens, there will be a distortion due to this angular misalignment. Spot size will be completely distorted. And spot characteristics continuously varies during the scan. That is what a limitation comes out to be here. To avoid this limitation, there should be a certain system which will maintain these two axes during the entire scanning. That is also one more requirement is there. So then another one, when we are going to have a problem, so another one is people have thought, why cannot we keep in a lens and resin surface? And will now only move the lens. I will not have any optical scanner before it, but only lens I'm going to move in X and Y direction. That also gives me scanning. And another one scanning is in a photoreactor tank scanning. These pictures have clipped it. Maybe this picture should be here and this picture should be here. So that is what this picture shows in off-axis scanning, and this shows in a photoreactor tank scanning. In photoreactor tank, that resin surface is XY direction moved. And due to this scanning, there will be this is nothing but a liquid you're going to scan. And due to this liquid scanning, what it happens, there will be a waves it will generate onto the particular tank. And due to this waves, there will be a limited accuracy you can get and very microstructure you can manufacture. And that is what also one other one disadvantage you can get is there will be a limitation on the fabrication speed. So these are the difficulties people face in different scanning systems. Then we decided, we came up with some reasoning, basic requirement of optical scanning for stereolithography. So we need an uniform spot characteristics. This, I don't want to change the spot during scanning anywhere on the XY plane. So that is what basically a limitation. Constant spot size should be there, uniform intensity into the profile will be there during entire range of the scanning. So that is possible only when optical axis of the lens and laser beam axis exactly match during the scanning, and you maintain the alignment over the entire scan range of it. So that is only possible. And we don't have any idea or any scanning mechanism to maintain this access. Then another one, to avoid this wavy structure, our resin tank should be in a stationary. It should not move at, and so that there will not be waves on the surface on the stage, and it will create a problem for this. So then we decided to go for this new kind of a scanner. You can just look at this particular picture. So when you are going to scan it this way, so that is a laser beam axis and lens axis, though both are maintaining the one single axis. And obviously during this one direction motion, you need not have any difficulty in maintaining both the axes. And obviously I can now tune up focus distance, and I can get exact spot here. And that spot characteristic is not going to change during the scanning. And then another direction, the same thing you can do it. So I can now traverse this all the three, that mirror one, mirror two, and lens in other direction. And whenever you are scanning, make sure that axis of scanning should be in the direction of the laser beam. That is also most important. This is what an idea. And most of the time, idea cannot be directly patented. Idea should be converted into some physical device, and then can be patented. It should have some commercial utility, and so that is what then it is a requirement. We'll discuss that part in later part of our presentation. So this now having a different idea, completely different from whatever the things we have seen. It is not the same as nothing is copied or nothing is the same in between previous scanning mechanism and this proposed scanning mechanism. Then obviously it is now, this is what an idea, it should be verified within a certain theoretical concept as well as an experimental concept. Then we decided to develop a mathematical model, which you previous lecture you have seen. We developed a mathematical for model for optical scanning as well as experimental setup for this. And then we compared both this. So whenever you are scanning from -4 mm to +4 mm, your spot is not going to change. But in other cases, you can observe there is a large change in the spot or spot on its characteristics. So this is what basically we got a major disadvantage of it, advantage of it. So we can go for this type of a scanner, and which will maintain the spot or spot size from one point to another point constant. It doesn't changes. Also, it gives in a constant peak intensity into this. So that is then we need to now develop an entire optical system. Around that, we need to develop um, mechatronics for this. That is what it is called as an optical system connected with a mechatronic system, that is optomechatronic system. What are the mechanism I showed you? That is a flexural mechanism. Also use the same sort of mechanism into this, so which will give me a better accuracy, maybe around about submicron or somewhere 10, 15 nanometer accuracy we can get it. So for that purpose, we have a two Y coil motors, and then D to A converter, current amplifiers, then there will be a D space, then optical encoder one and two, both direction motion sensing, then Z direction optical encoder. Then there will be a resin watt kind of system. Then layer thickness we can adjust by using a Z stage. Then there will be a switching of the laser on and off. That is what it is used, acoust-optical modulator. This acoust-optical modulator can give me a very fast switching. Why we need a fast switching? Whenever you may be knowing that we are using some cameras in previous days. So these are mechanical cameras. When we provide a button for it, what it happens, it will on that shutter will on and off it. So that is an entirely mechanical system, and that mechanical system has a limitation. It can switch laser or light on and off within a hardly few milliseconds of it. But if your scanning speed, you want to increase it very high, so that speed will not be, whatever the switching time is not sufficient. So for that purpose, we need a very high speed switching. That is what it is called as an acoust optical modulator use. So it is an optical system, and it will create an automatic rating whenever you provide a mechanical pulse for it, and based on that, it will divert the beams into two beams and kind of things it will be used. That is what an acoust optical modulator use. And this is now entirely one single system which will manufacture 3D components. And this is what in a typical demonstration I can show you for this system. Now, this is what on a laser beam. This is what on a switch, optical switch. You can see it. These are the mirrors, two mirrors for an alignment purpose. And this is what on a hole, pinhole through which that laser beam is going to pass, because you will get on a 2-3 beams. Out of that, we need to adjust for a high intensity beam, and that only you need to pass it. And then there is a scanning mechanism. It is on a precise scanning. Here you can see in a wise coil motors. There is an optical encoder. Then these beams are for an like high precise scanning purpose. And here you can observe it is an automatically switching the laser beam on and off. This is what on a stage on which you can manufacture 3D components. And here it is an entire tank, because it needs a very small liquid, and we should have a smaller liquid tank also. Then there is a jet stage. Jet stage is also spring-loaded jet stage we use it, and then we have a GUI for controlling this entire system. This is what an entire GUI. And whatever the controllers, back-end controller is nothing but an electronics devices. So these are the optical, that is a current amplifier, optical encoder. This is what an RF switch for switching on and off the entire system. So this is what again patented, and we manufactured few micro component, that is a micro pyramid. Base of this micro pyramid is approximately around about 1 mm, and top of this is 200 micron. Typically, I will give an idea that 100 micron means our hair diameter. We can keep hardly 2 hairs at the top of it. That is, diameter of the hair is 100 micron. So these are the micro cones, and downward circle diameter of the cone is around about 300 micron, and top is very less than maybe 50 micron or something. So then few more scaffold, then micro tanks, then micro channels, then so many other micro structures, axisymmetric structures, overhanging structures, micro voxels, so even micro pins. These pins having you can just imagine here it is this kind of a pin as again designed using controlling the laser intensity hitting to this. And that is what so these are the people involved in doing this entire work in IIT Bombay. That is Prasanna Gandhi was there, then Professor Kiran Bhole, then Amit Pathak, Rahul Ramtekar, and an entire team of this Suman Mashrawala Advanced Microengineering Lab, as well as supporter for this is Raj Mashrawala. He's an alumnus and owner of TIPCO Software Company. Many more people are there involved in developing this. Only one single person can't do all this stuff. Then now we'll look at it. These are the few case studies we discussed. And now we'll look at by step, what does that patent means. We gotten a new way of thought process. These few case studies will tell you what is the way we can go for new ideas. What is the way we can convert existing system into new way of thought process. Appa, direct pani de to ke glass. So we'll now look at what does that patent means. Patent is nothing but a protection granted by national government for an invention. So what is protection? What kind of a protection they provide? They provide a protection for your ideas. So that is what an intellectual property they call it. Similarly, way if you go and purchase a land, so procedure is that we'll go into the office at Howell office, and then we'll show them a drawing. This is what north south direction, all the drawing we provide to the that person, and based on that he will now given a authority to you people to operate or use that particular land, and he will charge for it. and maybe in some amount he's going to charge, maybe 50,000, or depends on the size of it. And that is what nothing but a property you have it. That is a physical property. I can show you. I can tell you that it's physical property. You got it. So similarly, if you want to have some intellectual property, like I have some new designs into my life, I want to have some new products, but I want this product should not be copied by anyone. So you individual, you can't control anything. So that's what government taken some initiative to for filing the patent, and that's what they have uh, decided to have some law for it. That is what in a patent protection law we can say. This is nothing but a patent is in a protection granted by any government, maybe not only Indian government, any outside government out of India also you can find so many places you can do it. So this protection excludes others for making and using and selling your invention for next 20 years of period. But in India, whatever patent you file it, from that day for next 20 year, you have an authority. After 20 year, you don't have any authority about your device. So keep in mind, because our life is short enough. So within these 20 years, you can make it product, you can convert into and you can convert into product and you can sell it to people. Many drug companies and university researchers seek the protection or to cover the research development costs for the patents related to the specific genes, proteins, laboratory techniques, drugs. So these are the research activity. एक वाजतील मला. हा. चालू करून दे ना तिकडे. एक पाच एकच्या आधी मला संपणार नाही. मला योगीराजचा नंबर देतात. आणि खालच्या रूमची चार्जेस नाही का? म्हणून मी लवकर येऊन बघतो. काम चालू एक नंतर ना. एक नंतर. So here we can have drug companies and university researchers want a protection for their work. So for that purpose, so there is a certain law for it. They want to commercialize it. For that purpose, we need to have the support of the government. So there, in order to patents to be issued to the granting agencies such as patent office, they need to new useful. They will go through your document, and based on that, they will decide whether it is to be awarded patent or some modifications are to be suggested or rejected, or somebody's copies that whole stuff they will identify, and based on that they will process it. So there will be a patents. Means patent is not only intellectual property, can be of anything. Like in a patents, it will be in terms of a patent, maybe in terms of copyrights, maybe in terms of trademarks or trade secrets. So it is an intellectual property. Is nothing but a creation of human mind. It is not a physical property or something. So which is protected by any government. Not I will say it is only U.S. government, maybe a certain law in fashion similar to the real property, piece of land or anything. And intellectual property includes these patents, copyrights. Under these copyrights, music is one of the copyright. Another is book is another copyright. Trademarks means you're going to create a brand for it, brand of the company. That is what comes under the trademark. Trade secrets means business secrets. So that also can be patented. So that is what basically a patent means. So now what is the basically history for this? In 1790, patent that US had started their patenting act at first. So they have decided why cannot we provide a protection for the intellectual stuffs, and then amendment have done from 1790 to so many till the date they have done so many amendments for this. Then, but in India, they have started this patenting in 1970, and they have done a few more amendment, three different amendment in 99, 2002, 2008, and these amendment are nothing but an addition of it. So, which will give a more protection or some more features about as per development or progress of this entire country, it will be decided. Then we'll just look at it is going to provide you a legal protection which gives an inventor to the right to exclude others for performing certain activity into the country of issuance. Country of issuance means this patent is mostly given from the country or government. It will not be globally accepted by all the countries. So we have more than 150 countries. So they may don't accept it. I can provide a patent in this country only. Means what are your ideas will be protected by region wise, not within a this worldwide. And this gives a monopoly for using this your idea for certain years. Okay, certain years. And whatever the disclosure made into your compound, whatever your document will be kept into the government website or government documentation, so that everybody will come to know, yeah, this is what it is protected. I can't copy it. And this does not give an inventor the right to make or sell the patented invention. Okay. So there will be most of the time people think what will be the difference between what are the scholar publications and what is the patent. See, patent means which gives you something new meaning for yourself, because you are going to have something innovative. You will be known for it. So inventor means you are having something new thought process you are given. So that is what it is called as an inventorship law. It is a matter of law itself. But in publication, there is no as such law defined for this. So publication means we have in some system and you have in a small modifications, and you're going to have in a research, or you are having in some ideas, and you are going to do in some experiment, and based on those experiment you are going to present in a document. That is what it is called as a publication. And here mostly this author, we can put one, two, three, four, or many also. There is no issue in it. It some practical work should be done onto this. Then and then we can have a result, and those results will be presented into the paper. Then future ideas can interfere, or previous ideas can be used, and we can go on doing the same type of work, and we can present the work as a scholarly publication. But in patent, it is in a constructive reduction to the practice. Means you want to convert your idea into the product, and product or is to be converted into market. Basically, intention is to provide commercial product, generate a commercial product out of patent. But in publication, this doesn't happen. And which is patent is nothing but it is a kind of I can say it is an asset for you, which will give you the money in future. So that is what the disclosure of the ideas for many future uses as possible to strengthen the patent. Also, it is possible. So what can be patented? Most important. So publications, we can do an experiment, re-experiment it, we can publish it, you can provide more and more stuff. But in patent, this doesn't happen. Patent can be done only once for particular idea or particular product. That patent is done at only once. It can't be twice, or cannot be go for multiple such things. So basically, this patent can be patented. Anything which you want to patent should have these conditions. It should be new or novel. Means novel means nobody has done it previously. That is what it is. A novelty should have. And next important point, these three part all the time we need to check it. The second point is in a usefulness. There should be a concrete or tangible uh, product it should convert, and it should convert into the money also in future. That is what it is called as a commercial. It should have some commercial aspect for it, and that is what it is called as a utility, you can say, or usefulness of that particular idea, invention, and your product. Then next one is it should be non-obvious. Obvious and non-obvious. Obvious means anybody can do it. This is obvious. I can do this activity or that activity. If somebody is doing some athletic activity, it is completely non-obvious to any other person, or some other idea which is not thought by any other person. That is what it is called as a non-obvious. And obvious means is it obvious to Fostia, for that is what a person having an ordinary skill in the art and cannot be found in a single or reasonable combination of the patents. Means there, whenever you file in a patent, make sure that it is what are the idea you are going to present it. It should not be there by any other mean also, and that is also to be avoided. So idea cannot be patented, law of nature cannot be patented, or any scientific principle also cannot be patented. Only idea it will not go. Means I will, what are the stereolithography part I told you. So there are two, three mirrors and then lens is there, and that much only if I'm going to file the patent, they will straight away reject it because this is a simple idea. So we need to convert that idea into product. We need to provide in a mechanical, mechatronics, or any chemical druggery system around it. And that is what it is expected. And if you convert that into the product, then it will be filed as a patent. So patent starts with an idea. There is no, I will not say ki idea is not there into the patent. Patent starts with a typical idea, which is innovative one. And that idea to be converted into certain product, commercial product or something. And then that can be filed in a patent. So whenever you are filing in a patent, we need to follow on a certain procedure. What are, see, when we are sitting at in one place and I want to file in a patent, so this is not going to happen. First of all, you need to identify the problems currently people are facing. So those problems may be from your day-to-day life, like in our corona condition is there. We people are now facing lot many problems. We need to have a mask wear, we need to have sanitization, so many things are there. So these are the day-to-day problems comes into this. There are certain industrial issues. Industrial part is there. In that industrial part, so industry works for certain product development or processes there. In that case, those you can identify certain issues out of it. You need to go for some innovative idea, then you need to go for. So that is what first of all you need to identify the problems. There will be a certain environmental issues. All these problems bring it and take up one single problem, then move forward. So that is what the next part is. What are the different problems people have solved? What is the way they have handled this issue? Corona problem. You just take an example of corona issues. In this corona, when you want to protect ourselves, we use a mask. This is what in one way people have used. Mask is previously used in by most of the doctors, so I can't go as in a mask as in a patent. Okay. So if I have something innovative into the mask, then I can go for an patenting. So to solve this, we can look into the different existing methods, tools people are using it. Then you need to identify what are the scientific tools and methods available for it. So now then we'll conceive a few ideas. I mean, maybe idea number one, two, three, maybe 10 ideas or kind of things. So 10 ideas you came up with. So these are new one, we think it. But so my experience is that when we started filing in the first patent, I may really collected more than 100 patents altogether. And then whichever idea I'm thinking, okay, I have to go for this as a patent. This is a new idea, I think, I feel. But whenever I put this idea into the net and search it, somebody has done it. So that's what we should know. What is current status of the technology? So that's what we need to concise all the ideas. Then you need to start the searching into the patent database. Once you search into the patent database, you will come to know. So first idea is already done by somebody else. Then second is also done by somebody else. Third is also done by somebody else. Then fourth, okay, nobody has done it. Now take up this idea and then create a documentation for this. And then this documentation is to be handed over to the patent office. And then patent office will now create a further procedure for filing the or giving a protection for you people for the patent. So whenever you are going to have a requirement, what will be the patent to be filed? What are the requirements of patentability? So first requirement, you can't say, "Okay, I got these results and I want to file the patent." You can't go for such things. What is the way? It should have a certain usefulness. it should be claimed as an invention, useful, or certain functional should be there. So that is what in a utility patent. I can tell you one simple example in this case. So usefulness means what? So most of the people are driving two-wheeler, and whenever they drive the two-wheeler, so two-person sits, driver and behind this. So we face some difficulty, and that's what we came up with a new patent, that is a footrest kind of a patent. So once it was happened in one accident, and due to that, it was accident was only the reason that that person want to open that footrest, and that is what he has done. He um, opened that footrest by hand, and due to that, that entire vehicle got unbalanced and they got an accident. Then it idea comes, why cannot we have some automated system for this? Then we decided to go for that. Then we decided to have some switch on to the back seat. That switch will get automatically on, and that is connected to your footrest, and there will be a springing mechanism which will open the automatically footrest kind of things. So that is, now I can provide this vehicle this one accessory for this vehicle, and that accessory can be used, and that is nothing but a patented. So I can't have a complete vehicle as in a patent, single patent. I can have multiple ideas or multiple products into the vehicle, and I can go for multiple patents into this. So that is what then you need to identify usefulness, and it may avoid an accident. It may improve the productivity of the system. It may be making you easy of use. That kind of things. That comes under the usefulness or utility of the system. A machine must work according to its intended purpose, and maybe a chemical must exist, an activity or some use also we can have it. So next comes is something new should be there. Nobody has done it. That is what it is called as a novelty. And third one is a non-obviousness or ingenuity. Means it should be something new. It should not be done as it is. So that is what the way you can have a patentability. Whenever we are going for a patent, so there will be three types of patent comes into defined by the governments. So first is in a utility patent, next is in a design patent, and third is in a plant patents. In design patent or utility patent, we just look at the patent. So issued by any process, machine, or article of the manufacturer, composition of matters, useful improvement, and kind of things. All these are includes into the utility. It has a certain utility. That's what it is. Name is given as a utility. It defines as a product. Okay, and that's what it is called as a utility patent. So example is I can show you that as blood warmer. Well, all the patents we filed as a utility patents. We never gone for a design patent. In this design patent, what is it should be a new one. It should have some original stuff. We never used it previously. That is what that is expected. Then there may be an ornamental design for an article of manufacturer, or any kind of an eyeglasses, some new design. It's not normal. If you want to improve the any aesthetic part, that is also comes into the patent. And third one is in a patent, that is a patent plant patent. Plant patent means you can hybrid it and you can create new one, reproduce it. Okay, that is what in a plant patents. So when we look at the patent and patent family, under this patent family means what it happens, it is a group of patent documents from different countries that protect the same invention. Now, I filed in a patent into the Indian context or Indian environment. Same idea will be there for out of the India also. So obviously that idea also to be protected, and this idea is also to be protected. So that comes under in a patent family, and will be a defines. It defines in a geographical scope of the patent protection. We'll discuss this in detail under PCT part of it, and it has a usefulness for locating alternate language version of the patent. And patent coverage only applies within the country that grants a patent, so that inventor must file a patent application in every country for the protection wherever he wanted. That is what basically, because government has a different rule. Each country has different rules. Obviously, we need to follow those rules, and based on that, we can have on a filing your protection in other countries. So when we are going to file a patent, we need to create a document, and that document tells you about your invention, and that's what it has in a only three stages it comes. So it comes into the cover page, under which can say key I want to file the patent. That's in a simple letter. It is given from the inventor to the patent office. So next parts is a card as in a disclosure or description of your or complete specification of your patent. So this gives in a clear. This should be written in clear and concise description of your invention, usefulness of your all the drawings, and it should must be so clear that if somebody want to manufacture, he can completely make it quite easily. So that kind of specification and each and every step should be included into this. So that is what basically idea behind this description. And what are the content of this? It is nothing but a title of invention should be there. It is a precise, it should not be very long title out, which will define, because whenever we are searching the patent, first we are going to search the title, and that title should be somewhat unique. It should be something different. It should not be repeated or something. Then statement of the patent history means what is the field, what is the work it has done it, what that is what in a history you can say, and what is the field of the invention, then background, and then summary of the inventions in the what are the invention in broader terms, what is the idea, and that is what we can say it is an abstract also. Then we need to provide appropriate drawings. Then we need to give a description of the drawings and detailed description of the entire invention. So that comes up into the description. And most important is in a claims. Claims means what ideas or what kind of a design you want to provide in a protection. Means that is provides a boundary for your protection. Boundaries of your patent protection. Means if I'm going to file the patent for blood warmer, I'll say there is a blood warmer. There is a mechanism consists of this, and working of this. This consists of this all component is one claim. Another one working of this entire stuff in appropriate sequence. Then it is another claim. Likewise, you can go on at least 3 to 4 claims. Don't go for more claims. Whenever you are going to write in a claims, make sure that it is going to cover broader perspective. It should not be in a smaller perspective. Just one example I can tell you. Few months back, one of my student came with me and asked me the idea that like whenever we go for a urine, so there isn't a problem that our automatic flushing system is there, but most of the time this automatic flushing system doesn't work, and maybe some electronics issues will be there, and it needs a separate power supply or something. Then he came up with some new idea that he want to file a patent with a mechanical system entirely. Mechanical system is that if a person is going to stand in front of that urinate box, then automatically water should deliver kind of things. He has created a mechanism with servo mechanism and something complicated mechanism he created. Then we searched onto the internet, somebody has done it. No, nobody has done it. Then we decided to file a patent. That is what when, but he want to restrict his patent within that particular purview of the urinate or cleaning purpose. Then I decided, why you're restricting for this? Why cannot what this idea can be used for any other purpose also? I can use it for washing the hands. I can use for controlling the amount of liquid in anywhere. And then we provided in a broader perspective for this, and which gives that patent can be now applicable for so many places, not only one single place. That is what the expectation. We need to define your boundaries of the patent, where it can be applied. And written statement of this broader will now decide whether it is to be protected or what is it is coming under that particular purview or not. So why to write? We need to give a more effort onto the claims than any other part of this. The reason for this, if somebody has copied your material, and you want a protection. If it is not mentioned into your claims, so if you are mentioning in this your entire description, that doesn't matter. If it is not mentioned in the claims, you don't have any rights to ask him to stop his manufacturing or pay for that patent. So that's what claims are most important. When you are defining the claims, give an appropriate broader perspective. Think in all aspects. So where I can apply this idea, and based on that, I need a protection. So that is what claims you can define, and claim should not be in a very large one, hardly 3 to 4 lines of the statements, and it should not be like an entire paragraph or kind of things. So whenever we are going to search the patent, so when you want to file in a patent, you need to search it. So what are the different codes for this? That are the identification of the data. That is number, agreed number for the identification of the data. So patent number is one, then document type is one, then application number is another one, patent filing date. Patent filing date is an important into this. So there will be if you are going to file in a patent earlier, that is what it is, gives you more protection. If you have come up with an idea, that's what government has given two options for filing the patent. One is you can provisional filing, and another one is a complete specification. In provisional filing, what is to be done? You can provide a complete specifications, hmm, within next 12 months of period. Before that also you can file in a patent. There is no harm in it. So date of patent, publication, issue, international, patent classification, domestic, whether it is a domestic or national specific classifications, what is its title, abstract or claims, then list of the art documents or pictures, or what are the names of inventors, applicants, grantees, holders, assignees, and owners. All this comes into this. So when we are going to have patents, these are the few international patents offices. One is Worldwide Intellectual Property Office. So that is what it is called as a WIPO. So then there will be a US patent office, that is USPTO. Then if you click onto this, there is an appropriate link for these offices. I'm going to share this PPTs. Then European office, they protect for a particular bunch of the countries. This worldwide means it is going to control over the entire world. Then Canadian patents will be for a Canadian part of geographical part of Canada, kind of things. And along with this, Canada may have some policies with other countries, and based on that, they will provide a protection in other countries also. That also is possible. For Indian Patent Office, there are 4 places. Offices are there. There is a Mumbai Patent Office, controls in Maharashtra, Gujarat, Madhya Pradesh, Goa, and Chhattisgarh, part of it. Chennai Patent Office will be in Andhra Pradesh, Karnataka, Tamil Nadu, Kerala, Pondicherry, and all the places. Then Delhi Patent Office is north part of the country, that is Haryana, Himachal Pradesh, Jammu Kashmir, Punjab, Uttaranchal, Chandigarh, all these places. And Kolkata is rest, that is east part of the entire country will be controlled under Kolkata. So why should we do the patent search? Whenever we do in a patent process, a patent is nothing but an expensive process. In India, it may need as a government fees, you may be going to pay up to 9,000 rupees to file a patent. It is nothing but it is a costly affair. That's what. Whenever we are filing a patent, your money should not go waste. So for that purpose, you need to have a strong reason to get approval of this patent. So that's what you need to have in a search. And also, search will help us to give you better and strong patent application. And you can have a new idea you can come up with. If you go on searching more and more, you will come up with new more ideas, and that is what basically reason. So whenever you are searching the patent, so there should be whenever you are searching the patent onto the website, I'm going to give the list of the few patent website search. So to be most effective in your search for the patent, you must determine how your invention works, not how you will use your invention. Means if I am going to use a blood warmer, so I could not put it in a blood warmer as a name for it. Rather than I will say automated uh, blood control, so blood temperature control system, temperature control of blood, like these keywords we need to identify. Okay, so for that purpose you need to make a list of entire words which will describe your idea. Okay, words, you need to define certain words or identify words and make a list of it, and now start searching these words by one. Maybe you can provide in a boolean logic like this and this word, this or this word, or this, so many words like this you can provide in a boolean kind of searches. And now you can search these terms into class, subclass of related atoms. Then first of all, before that, ask yourself what does the invention do? What is the basically idea? What is the idea, or what is its utility? What is the end result, or anything unique, special, and unexpected you're going to do it? What is it made of? Maybe in a method, maybe of a material, or maybe of a new fabrication or process technology, or what it is used for it. These are the questions you need to ask. And keep a track of useful and non-useful patents by patent numbers to avoid duplication of the work. So these are the most important searching tips you need to maintain whenever you are searching the patents. So when you are searching the patent, there is an appropriate process for it. So first of all, purpose of the search, you need to identify what is my purpose to search the patent. And if you're going to search it, this is what Google patents or entire internet is in a huge amount of information. All that information you can't read it, and you can't get all the things. So that's what you need to identify. What is exactly you want it, and based on that, you need to decide in a scope. Then once you decide the scope, then select keywords and prepare in a search qualities, and you can now provide in a combination of these words and go on extracting the data. Once you extracted the data, you will get so much of the patents, and then you need to segregate it. So this is useful, this is not useful, useful, not useful. Then again categorize it. Maybe some patents are talking about the process, some patents are talking about your new method or kind of things. You categorize this. Once you entire categories are decided, then you can now decide whether your patent somewhere matches with this or not. Then you can go on. So here there are free online resources. There is a patent scope. WIPO is giving you patent search scope. Then lens. Here it is in a WIPO. You will get an all PCT applications that into this. Then Google Patents is also there. All the places you need to search your ideas, and based on that only you can go ahead with this. So this is what a typical process for filing the patent in Indian context. So you first of all start here, means you have completed your specifications and everything. So this is what a provisional specification, or you can provide it. Once you provide in a provisional specification, you can file your complete specification within 12 months of period. Or else you can provide a complete specification at start itself. There is no problem. And yeah, your publication will be there the next. Nowadays, that time is hardly 5 to 6 days. It has reduced. So previously, it was taking more than 2 3 months period. Now they have increased the speed of publication. So publication is nothing but in a second stage into your patent, and this is what in the last stage where you're getting grant of it. Keep in mind, publication doesn't mean that you are the owner of the patent. So then now the office is going to provide certain, means they are going to discuss it whether that what are the document they have got it, wherever it matches they will compare it. Even they do so many examinations, so many things they do it, and they will provide you first examination report. And this first examination report, we need to provide a response for it. You need to, they may object, like your entire document is not patentable. There is no idea as a patenting idea or anything. And then it will go for reply for the examination. Based on that, you need to reply the examination. What are the questions they have asked? We need to reply for it. Sometimes they may say, okay, this idea is there in this patent, just give me a more explanation. That also you need to do it. Then after that, it goes to rejection or acceptance. So then, based on this examination, they will decide whether whatever the reply you are going to give. Based on that, they will decide whether it is to be accepted or it is to be rejected. And then you can deny the patent, or it will be granted for monopoly for 20 years. That is what the process will follow it. So this is comes under Indian patent filing process. So there are different modes of filing patent application in foreign countries. So there are two modes which are, I know it, I'm going to present it. One is a Paris Convention, and which gives a protection of industrial properties, provides 12-month time to file the patent application in member countries, and they have a bunch of the country within that your protection is allowed. But in PCT, that is what in a patent cooperation treaty system, that is what it is a PCT, they say. PCT is the system which allows the applicant to file in a patent contracting states within 30 to 31 months priority date instead of 12 months. And we can go for preliminary examination based on this. So PCT is the international treaty, and it has more than 150 contracting countries come together, and they decided. So if somebody is having a new idea, we can provide support for them. That is what an idea behind this PCT. And as per Indian Patent Act, has amendment in the patent rules amended by rules, that is 2016, any PCT international application may be filed designated in India, and it shall deem to be an application. Yes, it is compulsory. You can go ahead directly for an international filing also, and national filing also. So we need to just process that into PCT applications. So these are the PCT steps: filing the international application in receiving office, or it is a receiving office. Then international search by international search authorities, they do it. And then they will provide you international preliminary examination. And international preliminary examining authority will give you the one letter of entire examination. And based on that, you need to respond. And based on your response, they will decide whether it is to be granted or denied for the patent. So these are the few dates: are receiving office occurs an international filing date, date of receipt, so many things we need to go and to include, and we need to do it. International filing date is considered to be an actual filing date in the country designated in the request. That is what an advantage of PCT you can get it. So if I'm filing the patent in India today, okay, and I may be filing the patent after 6 months for an international, my protection will be there from this. If somebody has filed in a patent, whatever the information of yours, and later date of yours, you can straight away get support from government to protect your idea. If your filing date is previous, I mean, it's a later one, so you can't get any protection for this. So this is what a typical process. You can just go through this process. That is a PCT application. That provisional filing, you need to do it within 12 months, and then first filing in India, 6 weeks. PCT filing you can go. Then foreign filing permit, 21 days it will take. Then it will search report they will do. So they will go on whether it is yes, no, and then finally comes to the final international phase. That is what it does. So in US also the same procedure is there. There is no much more difference in it, but so that is in search the United States Patent Search Trademark Office, then find it, then determine it, then file it, and then go for an online, because they support for automated systems. That is what in register e-filer, then determine all those things. We can do it. Then you can review the process, then participate in the process, then provide an appropriate grant for it. That is what it does. So this is what a typical Indian patent process. That is a filing in India was filed in complete provision. If it is a provisional, then allow for more 12 months. If it is a complete, then go for publishing for 8 months. And then we need to provide a requesting examination. Then Within 24 months, you will get an examination report, then decision will be 36, whether it is a granted or refusal based on your response. So then conventional countries, if you want to go for another country or something, so you need to go for here one more book comes onto this, that is what a foreign filing permit. So that will be for 21 days. Once you file the patent for within 21 days, we need to put the same letter to the foreign filing permit and follow the same procedure. There is no issue in it. So most important in last statement, I can say there is an ideas cannot be protected. Invention can be, inventions are patentable. Already I told ideas means I have some idea and I want to file the patent. That is not anyway acceptable. You need to convert that idea into an appropriate product. That is what it is expected, and that is it is a expectation. So after filing the patent, what is to be done? That is also again a question mark. And we can develop your business proposal or model for your product, and you can start market search, get the money from the government or even banking, get the loan and start your business. And that is entire authority is given to you. Nobody's means if you have a patent, you can sell it to others also. There is no issue, difficulty into this. That is what the way you can do it. And there is one more patent for partnership. Is one program, and under this you can put your patent on USPTO site, and they will support you for in a business development, or they will give you a proper platform for market your patent. So there are a few problems which are I feel it I'm going to put in front of you. One is creating a model of the brain. And what does that model means? See, what are the information I'm storing into my brain? Okay, it is not increasing the size of the brain. It doesn't increasing the number of brain cells into my brain, but still it is storing more and more information. Like in our hard disk, if I fill up the hard disk 1 terabyte, then second terabyte, then third terabyte, likewise I can go on increasing the size of the hard disk. But our brain doesn't work on that fashion. It worked on mapping part of it. Mapping means it is going to have a curve fitting. If you have a data of 10 points you want to fit it, what do we do? You will fit the data within a simple equation, maybe in a straight line y is equal to mx plus c. In this y is equal to mx plus c, you're going to remembering only m and c, two parameters. Okay, and that is what it is called as an event. That two parameters are nothing but telling you the all the rest of the numbers. If you are going to provide few more numbers, what is going to happen? You are going to include few more data into this, and obviously you are going to modify this MNC. So do you have any system which will store this entire information by just creating some algorithms or mathematical tool which will store those entire stuff into a single hard disk or kind of things? That is what in a brain up model to store the information, and that it only needs a processing power, and hardly maybe in some few numbers we need to store, and continuously it will be updated. And these updated number will be all the time, it is going to store more and more numbers. That is what the way you can define the model of the brain. Next is we know that pollution is the major issue in all the countries as well as all the cities into this. So is there any system which we can mount it at the end of the silencer which will break up this all poisonous gases? So we can have, how can you do it? That is also one idea on which you people can think of to work. Third one is an artificial photosynthesis, because we are facing a more difficulty in pollution issues. We need to grow more trees, but trees cannot be uh, big within a night's time. So is there any system which will have maybe a paint or something? I can paint on the building, which is collecting the light, converting that light and minerals from the ground or something, and generating the oxygen, converting CO2, taking CO2 and converting it to the oxygen. So this is what in a nature driven process. why cannot we convert that nature driven process for an artificial one? So that is also one idea where you can think of to as in a future application or future of technology. So this is all for today's session. And if you have any queries or any questions, you can mail me also, you can call me also, you can ask now also.